Okay, so today we will be discussing about the classification of adhesives. And before going into the detail, let me tell you one thing over here that the adhesives are classified on different criterias on the basis of curing method. What method do we opt for the curing of the adhesive, of the coating? On the basis of the origin of those adhesives, and yes, of course, on the general classification basis, or let's say on the basis of the structure classification by structure of adhesives. So if we talk about the classification by structure, which we also refer to as general classification, adhesives are of three types: thermosetting, thermoplastic, and elastomeric. On the basis of curing method, we have two categories. One is one part adhesives and the second is the two part adhesives. Third classification criteria on the basis of origin, that means what is the source of adhesive, from where do I get the adhesive, whether it is a naturally occurring substance, or let's say the natural adhesives, or I synthesize them in the laboratory or in industries, then it is called as synthetic adhesives. Now let's discuss one by one into detail. So let's begin with the general classification. On the basis of general classification or the structure of adhesives, the adhesives are categorized into three categories: thermosetting, thermoplastic, and elastomeric. Now, as far as thermosetting adhesives are concerned, they consist of the molecules which are cross-linked by strong covalent intermolecular bonds forming one giant molecule. In other words, you can refer to the thermosetting polymers also over here, wherein we learned that the thermosetting polymers are those polymers in which the long polymeric chains were connected to each other by means of cross-linking, due to which the structure becomes more strong and it gave a harder structure. And yes, of course, the strong covalent intermolecular bonds existed there also. So likewise, we have adhesives also. And the cross linking, it is irreversible here. Therefore, these thermosetting adhesives cannot be reprocessed. We cannot remelt them and reuse them. That is impossible for the thermosetting adhesives. And the cross linking is achieved in the curing process, which is actually initiated by heat, or let's say by using some chemical agents, radiation, or even the evaporation of the solvents can lead to the cross-linking of the polymeric chain of the bonds. Curing results in the sharp increase of the strength of adhesive, of the elasticity, and the stability of the adhesive. In other words, you can say that the strength, elasticity, and stability of such adhesives increases sharply on curing of these adhesives. Most commonly used thermosetting adhesives are the epoxies, the polyesters, the polyimides, and the phenolics. Next is the thermoplastic adhesives. Likewise, the thermoplastic polymers, these adhesives, they do not have any cross-linking. So no new cross-link formation is there in these types of adhesives. So no chemical curing likewise. And when a thermoplastic cools, it hardens. So thermoplastics can be reprocessed many times, unlike the thermosetting adhesives, and it can be reprocessed as number of times by using heat. You can use the heat, you can simply apply a solvent, then the thermoplastic, it gets reprocessed. The molecules of most of the thermoplastic, they combine the long polymeric chains alternating with the monomer units. The examples of the thermoplastic adhesives are polyamides, polyacrylates, even the PVA, that is the polyvinyl acetate, is one of the example of the thermoplastic adhesives. Last of all, according to the structure, the adhesive can be elastomeric adhesive. Now, as the name suggests over here, elastomeric, that means it is ought to have some elasticity over there in the structure, in the properties. It will be showing the elasticity. So yes, of course, elastomeric adhesives are the polymers possessing high elasticity, and which may be reversibly stretched to a very high degree, and these actually consist of long lightly cross-linked molecules, means sometimes somewhere it is cross-linked, somewhere it is not inside the structure. And the elastomers are strengthened by thermal curing or solvent evaporation. So thermal curing here or the evaporation of the solvent from the adhesive can lead to the setting of the adhesive, to the let's say drying up of the adhesive, and technically saying to the strengthening of the adhesives. Curing results in increase of cross linking of the molecules. Examples are those adhesives which are based on the natural rubbers, the silicones, butadiene nitrile, that is, and neoprene, all sorts of rubbers. They form an example of elastomeric adhesives. They can be used in the making of elastomeric adhesives. So what do we find over here? We find a common feature among the three types of adhesives over here is that the structure of the polymeric chains, the structure of the adhesive, the overall linking of the polymeric chain, the overall structure of the polymeric chain, that leads to the differentiation of the adhesive over here. If it is not cross linked, okay, fine, it can be remolded, reshaped, and you can heat them, you can evaporate the solvent, and we get the thermoplastic adhesive. Okay, yes, of course, if it is not able to get remolded and the polymeric chains, they are cross linked with one another, forming a very strong and hard structure, then it is called as a thermosetting adhesive. And yes, if the adhesive has the molecules, the polymeric chains have elasticity which can be lengthened up to a high degree, and then also if the force is released, they come back to their original shape, then it is called as elastomeric adhesives. So it is basically the structure of the polymeric chains, the structure of the entire adhesive, the cross linking, the bonding, the chemical bonding which is involved in these polymeric chains, and the intermolecular forces, that leads to the differentiation of the three types of adhesives based on the criteria of structure. Second category of classification is on the basis of what we have picked up here is the curing method. So on the basis of the curing method, the adhesives can be classified into two categories, one part adhesives and two part adhesives. Let's discuss the one part adhesive first. Actually, it can be further categorized into heat activated curing adhesives, wherein the adhesives of this type consist of a ready mixture of two components, okay, and they are activated, they are cured with the help of heat. So hence heat activated curing adhesives. The second type of one part adhesive is the light or UV activated curing adhesives. Here the curing can be done or is done with the help of light or UV radiation. So which is and yes, of course, the UV radiation of appropriate wavelength. Now the adhesives of this type, they usually contain the photoinitiators, because you know it well that the photoinitiators are the molecules, are the species which actually initiate the further polymerization reaction when the ultraviolet radiation is subjected upon it, and hence enhancing the curing reaction. So one part adhesives basically consist of a ready mixture of the components of the two components which can be cured by heat or by UV radiation. And the examples of one part adhesive heat activated such type adhesives are epoxies, urethanes, and polyimides. Another type of one part adhesive is the moisture activated curing adhesive. Remember, this classification is on the basis of curing method. So accordingly, we have up till now we have discussed the one part adhesives which can be wherein the ready made mixture is there, okay, and this mixture, of course, it can be cured with the help of heat. So we have heat cured mixture, and it can be cured with the help of UV or light. So we have light activated adhesive. And yes, if it can be cured with the help of moisture, so moisture activated curing adhesives. These adhesives are cured when they react with moisture which is present on the substrate surface, or rather in the air. The examples of moisture activated curing adhesives are the silicones, RTV silicones, the urethanes. They are the moisture activated. They can be used for the preparation of moisture activated curing adhesives. Next is anaerobics, means no air, no oxygen supply required for curing. So your surface should be deprived of oxygen, or let's say it is used in those parts, in those applications wherein the oxygen supply is not there. So there are certain examples of anaerobics, that is the acrylic based adhesives, they are anaerobic. So basically how the curing is taking place: acrylic based adhesives, they are cured between the metallic surfaces, the surfaces of which are deprived of oxygen. Next is a pressure sensitive adhesive, PSA. As the name suggests, they get cured when the pressure is applied. So adhesive of this type do not cure. Actually, adhesive bonding is forming between the adhesive and the substrate as a result of the pressure which is applied to the substrate. And the adhesion strength, the strength of the bonding, the strength of the adhesion, it is determined by the pressure with which is applied upon the substrate. So higher the pressure you apply, stronger will be the bonding, more will be the bonding areas of the adhesive with the substrate, and yes, of course, more adhesion will be achieved. The typical examples of this type are the self stick tape, or you have the double sided tapes. They all are pressure sensitive adhesives. So that was the story as far as the one part adhesives is concerned. Coming to the two part adhesives, as the name suggests, two part. So a two part adhesive, it gets cured when its two or more components are mixed together. So randomly speaking, or generally speaking, actually these types of adhesives, it consists of two parts, or more than two parts, can be more than two parts also. When they are mixed, then curing takes place. The component react chemically, forming the cross links of the, or the cross linkers of the polymer molecules. So the two part adhesive examples basically are the epoxies, the urethane, silicones, acrylics. So if you consider all the general conversation up till now, we come to know that on the basis of the general classification and on the basis of the curing method, we can make out one thing, that the epoxies and polyimides can play a role in one part adhesives, subcategorized into heat activated curing methods. They can also be used for thermosetting adhesives, and as well as, if we go further on the basis of the origin classification on the basis of origin, they can be an example of synthetic adhesives. Classification of adhesives on the basis of origin. As the name suggests, from where do we get the adhesive? So if we are able to get the adhesives from natural sources, or they are called as natural adhesives or glues, like for example the animal glue, which is prepared by boiling the animal bones and the connective tissues containing the protein. So therein we get the glue, which is the animal glue. We can also get the glue from the casein, which is made of skimmed milk. So because the main component of the this casein is protein contained in the cow milk. Third category can be a fish glue, made up of fish skin, which actually contains the protein or the collagen. So wherever the collagen protein is present, you can make a glue out of it, casually speaking. Vegetable based glues are also there. For example, you get it from potato, from the tapioca paste, from the starch glue, the soya bean glue. It actually consists of aqueous dextrine based glue. Natural rubber is the one of the, I should say, the one of the oldest glue, which is the latex glue. Natural rubber glues are prepared from water based latex emulsion, which are basically plant origin. The second type of adhesives on the basis of origin are the synthetic adhesives. For example, you have epoxies, you have polyurethanes, you have polyimides, you have acrylics, you can have polyamides also prepared in the laboratory, so thereby forming an example of synthetic adhesives basically synthesized in the laboratories.